Hello and welcome to another video lesson with Mr. Roman. Today we're going to be looking at adding and subtracting polynomials. And this video will be in two parts. So this is part one following your notes. So we're going to define like terms as terms with the same variables raised to the same powers or raised to the same exponents. And so below this space in your notes, you have a spot where there's a lot of terms listed. So we're going to take a look at circling the like terms in this image. So let's start with 5x squared and negative 5x squared. So they both have an x, and both of those x's are to the second power. So those are considered like terms. The second pair is 3xy and negative 8xy. And then the third pair is negative 2x squared y and positive 1x squared y. And notice that the two purple ones are not like terms with the two pink ones. And that's because the purple ones have the x to the power of 2, whereas the pink ones have the x to the power of 1. So there are different terms between the pinks and the purples. The next pair is negative 5xy squared and positive 8xy squared. And again, the two black ones are not like terms with either the pink or the purple ones, mainly because the squared, the exponent of 2, is on the y, not on the x. The next pair would be the 4y and the 6y. The next pair would be the 10x and the 15x. The next pair would be the 4x to the fourth and the negative 8x to the fourth. The next pair would be 3y to the sixth and negative 1y to the sixth. And then, of course, the last pair is 7x to the seventh power and negative 2x to the seventh power. So in your notes, you have a space for definition. And adding, subtracting polynomials, we're just simply calling that combining like terms. Okay. Now, the next five definitions, this is more for vocabulary while we're speaking and talking in class. So a monomial is mono, the key word there, meaning one. It's an expression with one term. A binomial, which if you relate that to like a bicycle that has two wheels, a binomial has an expression with two terms. A trinomial, or relating that to a tricycle has three wheels, so a trinomial is an expression with three terms. And then a polynomial or polynomial, poly meaning many, that's an expression with two or more terms. And then lastly, the standard form of a polynomial is simply arranging the terms in descending order of the exponents. So we would want to have the largest exponent term first, and then the next largest, and the next largest, and the next largest. So descending order by the exponents. So the first example in your notes, we have a binomial here in the first parentheses, and we're adding that, so you see that big plus sign between the parentheses, we're adding that to another binomial. So when we're adding two polynomials or two binomials, we can ignore the parentheses here because they're not going to be necessary. And so I'm going to simply color code the like terms. So to start with, the like terms we see are in red, and the green and the blue term, they are what I call a loner term. They don't have anything that's like them. So those loner terms, we're just going to rewrite in the new expression. Start with the 5x squared. And then when you combine the red terms, you get a positive 3xy. And then you would just bring the other loner term down, the negative 3x cubed. Now, this is not in standard form because our largest exponent is the x to the third power. So that needs to be first when we write it in standard form. And so what I've circled here in purple is writing the expression in standard form of a polynomial. Next, let's look at example 2. Here we have a trinomial plus a polynomial. So the first set of parentheses has 3 terms. The second set has 4 terms. And again, this is a plus sign between the parentheses. And so again, we don't need to worry about the parentheses here. We can really ignore them. So I'm going to color code the like terms. And we're going to start with the blue term. So y to the fourth and a negative 2y to the fourth combine to give you a negative 1y to the fourth. Then the negative 3y and the positive 2y combine to give you a negative 1y. And then the green, you get a positive 7 and a negative 11 combined to give you a negative 4. And then lastly, that black term, it just tags along the 2y to the third. Now, to put this in standard form, we need to rearrange the terms. So notice how I've got the fourth power, then the third power, and then that negative 1y, that red term, that has an understood 1 exponent, and so that would obviously be the third. And then the constant is the negative 4. It doesn't have any variables on it. Next, we have a trinomial in the first parentheses plus, so see the plus sign between them, another trinomial. And again, since we're adding the two polynomials, we can ignore the parentheses here. So let's highlight or color code the like terms. There's two loner terms here. So the 5x to the fourth in green and the 3x in black. Those are two loner terms. So that 5x to the fourth is going to stay the same. Then when I combine, the 3x also stays the same. And then when I combine the constants in red, negative 2 plus 4 is going to give me positive 2. And when I combine the blue, that gives me 0. So a 1x squared and a negative 1x squared, those combine to give me 0. So this expression here is already in standard form, so we would just go ahead and circle this as our final simplified expression. And then the next example, we have a trinomial plus another trinomial. And again, we're adding the two polynomials together, so we can ignore the parentheses for now. And let's color code our like terms. And so let's start with the red. That red term, that's going to be a loner. There's nothing else that combines with that. And then the black term, that's also a loner. So we're going to just jot that down. Next, looking at the blue terms, negative 2x squared plus a positive 5x squared is going to give me a positive 3x squared. And then the green terms, we're going to say is negative 3x to the third y. Because here there's an understood positive 1 for the green, and here there's an understood negative 4 for the green. So combining those, you get negative 3x to the third y. So now we need to put this in standard form of a polynomial, which I've circled here in purple. Now, the next question in your notes says, what do you think we will do differently when we subtract polynomials? So far, we've only looked at adding the polynomials. In the next video, we're going to look at subtracting the polynomials.